Good morning, students. As a continuity, today we will see Dielectric Materials Part II. We know dielectrics are insulators, but it polarizes or an induced dipole is produced in the presence of external electric field. As a result, charge displacement takes place and a very minute current flows. Suppose if the applied electric field is large beyond the critical value, large current flows due to more charge displacement. At this point, the dielectric loses its insulating properties and becomes conductor. This process is called dielectric breakdown. The normal insulating behavior breaks at this point and changes to conductors. The dielectric field strength at which dielectric breakdown takes place is called dielectric strength. Based on the medium and other external factors, the breakdown mechanisms are of five types. The first is intrinsic or Avalanche breakdown. When a large electric field is applied, there is more charge displacement and results in electrical breakdown due to physical deterioration, nothing but weakening the dielectric material is called intrinsic or Avalanche breakdown. This phenomenon is experienced in our daily life when there is a high voltage drop, the electric fuse goes off and trips down. Another example is sudden electric spark appears in the circuit due to weak or low quality dielectric materials. The second type is thermal breakdown. Here, when a large electric field is applied, more current flows, so the excess power or energy is dissipated in the form of heat, which can melt the dielectric material. Such a breakdown due to rise in temperature is called thermal breakdown. These pictures clearly show the difference in breakdown at same point but are due to two different mechanisms, the avalanche breakdown and thermal breakdown. The third type is chemical or electrochemical breakdown. As the name says, this breakdown takes place in solution or medium with two different phases like solid liquid, solid gas or gas liquid. Again, when a large electric field is applied, there is a rise in temperature and this results in displacement of ions in ionic solution and produce large leakage current. When this current comes in contact with the combustible materials nearby, can even result in explosion. Example, sudden fume liberation or crackling sounds produced in chemical experiments. The next type is discharged breakdown and it takes place in gas molecules. When large electric field is applied, the gas molecules will ionize very easily and produce large ionization current which results in discharge breakdown. The first picture shows the recent oil warehouse fire accident in Madhavaram due to chemical or electrochemical breakdown. The second picture is the scintillation glass chamber. Inside, a gas discharge breakdown takes place and an electric white sparks are produced in the form of thunder. The last breakdown is the defect breakdown. This is due to the presence of surface defects like cracks, porosity, blowholes, impurities like dust and moisture it present during the manufacturing of dielectric materials and will result in current discontinuities and breakdown. Among the various dielectric materials, the ferroelectric materials are the most important. Ferroelectric materials exhibit spontaneous polarization even in the absence of external electric field. The very good examples are barium titanate and Rochelle salt. Students, Ferroelectric materials have very similar properties of ferromagnetic materials which we have studied. So the properties are they exhibit spontaneous polarization, dielectric hysteresis curve, that is the amount of polarization induced as a function of electric field. Above the Curie temperature, the ferroelectric materials are converted to paraelectric materials. They exhibit both piezoelectric and pyroelectric mechanisms. Hope you can remember, piezoelectric is polarization induced due to mechanical stress and pyroelectric polarization induced due to rise in temperature. Based on these properties, the applications of ferroelectrics are piezoelectric materials are used in pressure and ultrasonic transducer. Pyroelectric materials are used in infrared detectors as they are the functions of temperatures. In optical communication, ferroelectric materials are used in optical or light modulation. With this, we have come to the concluded of Unit 4 and Dielectrics. Thank you.